and welcome to day 6 of the Advent of Codemas, 12 projects of Codemas.
This is going to be so cool. I wonder what we're doing next.
Don't know, you do the honours.
Last week we got a speaker buzzer thingy.
That was yesterday. Keep going.
Last day yes day.
It wasn't last Christmas either. Keep going.
Resistor and some male-to-male wires.
Resistor and, and
an
an
LED.
Okay, cool. So a resistor and an LED. I wonder what we're going to do with it. It looks like we're adding a fourth light. Ooh.
Wait, what will we do with the fourth light?
I don't know.
Is it? It's not RGB, is it? Because it doesn't have 3 thingies.
It doesn't have 3 legs, no. Okay, here is the website. So day 6, looking for light. So, oh, wait a minute, that's not an LED, and it's going to be quite hard to tell, but that's a light sensor. Ah, you know how we can tell that's a light sensor?
Because it's weirdly circular.
And it provides us with a reading value, which we can detect for light. So it's able to provide a range of values. So, okay, going to be like the ADC. So we've got a photo transistor, which is that thing, a 10K resistor, maybe, and some male-to-male jumpers. So today's project, we're going to take more analog readings. Very nice. So when they say remove everything else, I'll do the removing bit, I guess.
Yep, I'm up for that.
So they're also, yet again, removing the controls. Okay, it's interesting. I mean, it's not horrendously complicated. There we go. And then we're going to go and grab the mini breadboard. Oh, so we've got to remove everything from the mini sensor as well, mini breadboard as well.
Oh well.
And now you can fit the sensor with the long leg to the left.
We need the other breadboard. Does it matter where it... Yeah, it does. Does that work?
Now we've got these 3.
With this.
Yep.
That's a lot of wiring.
I'll show you the back of the craze sometime, then we'll talk about a lot of wiring. Light sensing. So we're going to be using ADC, we're going to be printing it out. So I'll copy this over, and while I do that, Phoebe is plugging this in. Boop. Day 6, light. Daylight. 6371. We're going to be seeing a lot of light because we've got that great big light over there. But...
Can I move it into a shady area?
Well, I was just going to cover it with my hand. I can't actually see the play button now. Hurrah! Okay. Big A, yep.
I don't think it works.
I'm not convinced by that, no. While true, print the value. Let's run that. No, that is so not sensing. 3 volts, 4 pins over the grey wire, and that's going across to our ground. And
Dad, all of those wires are flapping around in an annoying way.
And this, ladies and gentlemen, is why we use solder. I'm going to try reversing the photo transistor. It's not going to explode, Phoebe.
I want it to explode. Wait, no, I don't.
Didn't make the blindest bit of difference. So, rule of debugging electronics: thou shalt measure voltages.
Voltmeter time!
Mm-hmm.
As soon as he got into his special wheelie thingy, I was like, he's getting the voltmeter thing, but I didn't know how to name it, so I just said, you're getting the thingy meter.
From the thingy with the wheels, the toolbox. I'm getting the electric measuring stuff from the tooling storagey stuff.
Yeah.
Phoebe loves that word stuff. Ground. And here, which is supposed to be 3 volts.
Don't short circuit it if that's a thing.
Yeah, I won't. Famous last words. Okay, so it is nearly at ground. Oh look, and
Why is it minus? Oh, because you flipped it.
yeah. So
25.
25. Now, if we cover this, tell you what we need. Have you got? Can you go get a pen lid? Because a pen lid would be a fantastic way to cover that.
How big?
Normal sized big pen lid, like a biro lid. Measure our output pin, which is this one over there. Right.
Nothing.
So if you now lift the pen up, lid up, sorry. Ah!
It is working.
So put it back over again. Well, it's responding. Put it over. Why is the Pico not responding? Okay, so we've uncovered something.
It's the Pico.
So we've moved that over to what should, I think, be pin 27. So if I load code with pin 27, we're getting another random, it's just this value.
Is it? It can't be in the code. Oh no, it does change.
Ah, hold on, I know.
Light sensor isn't changing.
Import time. Right, I've stuck in a time.sleep in my while loop, which is, we might have been fighting the fact that this serial gets kind of, what's the word, backed up and buffered up. Oh my.
No, it does work. Never mind, we were completely wrong.
It was nothing to do with the electronics. I did not need the multimeter. It was all to do with me putting it in the while loop, and I broke it by having no sleep. Hurrah! So always have a little sleep in your while loops, because otherwise it just, it'll back up and buffer up the serial pool. Hold on, do you know what I'm going to do?
What?
I'm going to switch that pin back. I'll switch that pin back. Move it there. Right, I've switched back to the original pin, both in the code and on the device. Let's see if that's all. Oh dear. So it was nothing to do with the resistor, it was nothing to do with the
So we
wiring.
spent like 10 minutes doing nothing.
But we have remembered that a pen lid is a really good way to interact with this. So that works, and that was a bit of a problem exists between chair and keyboard of my own, because I got clever with the code.
Okay.
So, activity 2, making light readings usable. So it turns it into a percentage. These 2 lines.
And you're going to copy it into your forever loop.
Yes, exactly. So we'll put that in here.
You are so very predictable.
Yeah.
Oh,
So
yeah, that works.
it took a while. The graph had to take off the things that were in the 60,000s, otherwise it was never going to show the 100,000s. Right, there we go.
Yeah.
So if I point it at that light source, it's 100%. And if I put the pen lid over it, it's 0%. And if I put the pen lid
1%.
somewhere in the middle, can I get 50%?
You can.
It's analog, so it's never going to be totally stable. Let's go. Next example. I wonder if they're going to back to where we put it. Example 2. So you notice, although I was looking at the graph, which is good fun, we've got like 5 decimal places over here, rounding it to 1 decimal place. So look, now we've only got 1 decimal place there, although we've got these few interesting... Do you see those?
It doesn't work some of the time. What?
No, it's converting to a decimal place, 1 decimal place, most of the time, and it's approximating it some of the other time. Adding the percentage, so we can actually say the percentage, i.e., 36% or what have you, and they're printing it with this lovely percentage. You see, and they're doing this old school Python. I'm going to show you a trick. Right, we'll save that, and that gives you a percentage sign.
Mm-hmm.
But actually, this is where I find they do it in the very next exercise, isn't it? I prefer to use F strings in Python.
Oh yeah, you've talked about these.
Because I think they're a much neater way of expressing the same thing. And if I hit the play button, it does the same thing, but that's not all it can do.
Why is it still so buggy?
You mean with the 0.0s? Well, so if I say 0.1, if I do F, I can't remember if I need the F. There we go, that's less buggy. Colon 0.1F, which is a format specifier saying...
For one figure.
Yeah, truncate all the other figures. So, next example, light level LED indicators.
Let's do
Okay, so what are we doing? We're going to set up the LEDs. We're going to have to probably... And they got a time sleep of 1 second. We'll be changing that.
0.1 seconds.
Yeah, exactly. Responsiveness. Day 6 LEDs.pi 0.1.
We ain't gonna wait 1 second.
Nah. So if I go... Oh, can I get it to...
Technically, do our eyes do this all the time?
Oh, what, measuring light this way?
Yeah.
Yeah, I think so. I'm trying to get it to stay on amber. That's quite tricky to get it to stay on amber. So amber is when I get the graph. If I can get it just about 50%, you get amber, green at the top, red at the bottom.
Fun. How do I get red?
So we could add some buzzer code from yesterday to beep when the alert goes below 30. That would be day 6 complete, sorry. I said day 5 again. Yes.
Yeah,
okay.
I still think it's day 5 in my head.
I know, somehow it's moving too quickly. Right, so look, when it's below 30, we could put a beeper in then. So when it's dark, too dark, it beeps. How are you going to tackle this? Are you going to do a whole tune or just a buzz?
Just a buzz.
Okay, just a buzz. In which case, if you just wanted just a buzz...
When it goes below...
30.
Below 30.
Because we haven't got that, and you're going to need to make sure you've got PWM as well, because we haven't got that either. Play tone, just use the word for number 440. We don't need to copy all those over for now. Where's it checking for less than 30?
Oh, that's less than equals. Oh, okay, that makes more sense.
Mm-hmm.
Play tone.
Note volume, delay 1, delay 2. So we can
Note
say
440.
Okay, I've got another idea.
That's pretty cool.
I got one. I've got another hack.
Or
I got a hack, and you're going to love it or you're going to hate it. A while true, read the sensor. I'm not going to bother converting to a percentage because I don't believe it's needed. Tone equals, let's say 1760 times light percent divided by 100. I'm not going to round that. I'm going to int this. Something like this. That'll be the tone, and the volume, I'll make it 10K like we had before. Print it. Day 6, light instrument.
yes.
This is either going to be really cool or
really
you're
good.
going to really hate it. Are we ready?
No, never have been. That's kind of cool.
I'm not going to be able to say I could play a tune on it, but... Now I'm doing it in steps that are going to be, well, yeah. Now lift it up slowly. See if you can reach 50% and hold it. Up. On that note, I think we're going to end for the night. I hope you've enjoyed our what became a very noisy journey.
As much
into
as
light
we
sensors.
did.
Oh yeah, I enjoyed
That
that.
was so fun.
Go make stuff and be awesome.
And we hope to see you in the next one.
Bye.
Bye. I think
Kind
it
of.
thinks it's a tiny spider.